This is Josh White with JW Math Tutoring. Today's video is going to focus on 10 problems from the November 2024 Digital SAT Math section. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Before I begin going through the problems on this November 2024 Digital SAT Math Part 3 worksheet. I just want to mention a couple things, that I mentioned at the start of each of these videos. First, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, most of these problems are going to be done as free response questions. However, some of these most likely appeared as multiple choice questions on the test. So there may be other methods that you could use to solve some of these problems if if they were multiple choice questions, like a back solving, plugging in the answers, those kind of things. So just keep that in mind. Otherwise, let's go ahead and get started on the first question here, where we have an exponential function. They tell us that it passes through these 2 points with a constant of c in them, and they want to know what could be the value of b. So first I will show you, I guess, what I would consider the traditional way to solve this, and then after that I'll show you the much quicker, easier, faster Desmos method. So the traditional way to solve this would be plug in these 2 points. So for example, the first one, you would get 8. You plug that in, for your f of x or your y. And then you've got a to the c minus b. And then when you plug in the second point, you've got 190 equals a to the 2c minus b. Now, at this point, what you can notice is that if you solve this first equation for a to the c power, it turns into b plus 8. And now you can go to the second equation and you can replace a to the c with that. And the way this is going to work is a to the 2c is just the same thing as a to the c quantity squared. If I just rewrite this, because when you raise to a power, you just multiply the exponents. And now you can substitute in for a to the c the b plus 8. So that's going to be squared. Okay, then you're going to FOIL this out. So it's going to be b squared. I'm just going to skip some of the steps. It's 8b plus 8b is 16b, and then plus 64. And we still have the minus b at the end here. Now, if you get everything over to, let's say, the right side, and we get 0 equals b squared plus 15b, and it's going to be minus 126. Now you can solve this either by factoring it, or you could at this point go to Desmos and just punch it in and see what the x-intercepts or the zeros are. I'll just show you. It's going to factor as b plus 21 b minus 6. So you get b equals 6 or b equals negative 21. Okay, negative 21 is not one of the answer choices. It is 6. So the correct answer for this is letter A, 6. Now, here's how you could do this in Desmos. And again, this will be so much quicker and so much faster. All right, just want to shrink this down a little bit so we can get the problem and the graph on the screen. All right, so first thing I'm going to do is I am going to enter in a table and I'm going to put in these 2 points. Now, I'm using C, but don't worry about that. I'll talk about that in a second. Next, I'm just going to do a regression, specifically just exponential regression. So the exact format that the function is given in. Okay, so I've got c comma 8, 2c comma 190. Those are my 2 points. I've got a slider for c, which I'll talk about in a second. Okay, now I have my regression statement here. Okay, and it gives me a value of b equals 6. Now, this is for c equals 1, but what happens if I change c to a different number? If you notice what happens with the shape of the graph, the a value is what gets adjusted. The b value never changes. The b value is fixed at positive 6, okay? Even if I go all the way here to 10, even if you go into the negatives, the b value is still fixed at 6. Essentially, the b value, um, like the 6 in here, in the actual function, it's -6, which is serving as a horizontal asymptote. But anyways, this is how you could do this in Desmos. You just use a slider for C, and then you can just move it around, just confirm it says it's 6, and that's the answer. All right, so looking at this next question where we have two square pyramids. So essentially what's going on is the base of each of these is 144. That means they're each 12 by 12 because it tells us they're squares. Square root of 144 is 12. But they have different heights, okay? So one of these has a height of 11, the other has a height of 22. What's the difference in the surface area? Specifically positive difference, meaning larger surface area minus smaller. So what you have to do is go through and calculate the surface area for each, and then go ahead and subtract the two figures. So for the surface area of a pyramid, you've got the area of the base, which we already know, 144, and then you have to find the area of the four kind of lateral faces, or the four triangles, calculate that. So the way this is going to work is essentially you're going to have a right triangle like this, where this leg is basically half of the edge, i.e. the side of the base length. So this would be 6. Say here in this first one, the small one, our height would be 11. And then the hypotenuse is L, which is going to be the slant height for one of the triangular faces. So you do 6 squared plus 11 squared equals L squared. Now, this is going to just work out to 36 plus 121. Let's get rid of this. Equals L squared, or basically L is going to be root 157. You do the same exact thing for the second one, except it's now 6 squared plus 22 squared. And then that's equal to L squared. So when you do that, you end up with L equal to the square root of 520. And you could do these in Desmos and get the decimal values, like that's fine. You would just, if the answers, for example, if the answers had square roots in them, you would just have to type them in to figure out which one was equivalent, to the decimal value you get. All right, so now that we have that, we can start with the small one. Start with, I'll put small and big over here. Okay, so for this one triangular face for the small, we've got 12, we've got square root 157, so our area is just going to be 1/2 times 12, then square root 157. Or in other words, 6 root 157. Okay, again, that's the area of one triangle, but now for the total lateral area, we would just multiply this by 4 because there are 4 triangular faces. So 24 root 157. Then for the big 12, again, this is going to be root 520. Maybe, I mean, 520 can be simplified, but whatever, I'll just leave it like this for right now. So the area for one triangle, again, 1/2 times 12, which is just 6, and then root 520. 6 root 520, and then you got to multiply that by 4, so it's going to be 24 root 520. Okay, so now we can get the total surface area and subtract them. Although what's going to happen, you see, is since the base area is the same, when we go to subtract those, they're actually going to be, like, they're just going to cancel out. They're not going to matter. So total surface area for the small one is going to be, the 144 plus 24 root 157 centimeters squared. Total surface area for the large one is going to be, again, 144 plus 24 square root 520 centimeters squared. And we subtract these, and since it says positive difference, we want, big minus small. So you can see the 144 is just going to cancel out, and then you're just going to be left with 24 root 520 minus 24 root 157. Now, perhaps, the numbers work out in the problem such that they're much nicer to work with than these random radicals like I had, but this is still the same general process you would go through. Um, and again, square root of 520, that can be simplified some more if you want to. I'm not, going to bother doing it now because I don't have answer choices to choose from. But this would basically be, your answer right here. You could also technically factor a 24 out front, as a GCF if you wanted to, and have something, just like this. But that really doesn't make much of a difference. But this is the basic process. These are the steps you're going to go through. Okay, just let's look now, problem 3 at the bottom of the page. So here we have a circle inscribed in a square. So here is our square. Let's see if I can get an appropriate circle inside it. Okay, perfect. All right, the square has a diagonal with a length of 164. So here's the diagonal. Going like this, it'll pass through the center of the circle. I want to know the area of the circle. So you can get the sides, of the square in two different ways. You could technically use Pythagorean theorem. You could say these are the same, so they're x and x. And it's x squared plus x squared equals 164 squared. 2x squared equals 164 squared. X squared equals 164 squared divided by 2. Basically, then you could square root both sides, and the 164 squared becomes 164 over root 2. Okay, and then you could root 2, 164 root 2 over 2, cancel this out. Okay, so each side is 82 root 2, and that's it. Now, if you recognize also this is a 45-45 triangle, right triangle, when you have a square and you draw the diagonal, you could go through that approach as well. Meaning, what you recognize is the scale factor essentially between the hypotenuse and each of the legs is square root of 2. And so when you're going from hypotenuse to the leg, you divide by root 2. And if you were going from leg to hypotenuse, you would multiply by root 2. So if you recognize it that way, that's fine as well. Okay? So now what this means is for the circle, the radius is basically going to be half of the side length. So in other words, the radius would go from here to here, so it's going to be 82 root 2 divided by 2, which is 41 root 2. So now to get the area, we can plug that into the area formula, pi r squared, and we have pi, and we have 41 root 2. Okay, now we can just go ahead and square the radius. So 41 squared is going to be 1681, and then root 2 squared is just going to be 2. So when you multiply those together, you should just get 3362 pi. So that would be the area of the circle. And we can just confirm this. Actually, we'll do it this way in Desmos. Yep, 3362, and of course, don't forget the pi. So that would just be our final answer for this problem. Our next question, number 4, top of the next page. This is basically a repeat question, one that you have seen before, both on official tests and also in the Blue Book app. The product of the roots here is equal to 84. And so all we have to do is find the three roots, multiply them together, set that equal to 84, and then we can solve for the value of k. So the first root coming from here is going to be negative 7/3. You just set this equal to 0. You subtract 7. You divide by 3. Now, for these two here, basically you set each of them equal to 0. I mean, that's what you do for all of them. And then for the first parenthesis, you just subtract this square root 5k minus 4. So your root is just going to be negative and then square root 5k minus 4. That's it. Same thing here, you're going to add the square root of 5k minus 4. So the actual root you're going to multiply is just square root 5k minus 4. Set this all equal to 84. First thing I would notice is two negatives make it positive. Also, when you multiply these together, the roots will cancel out because they're the same expression, and you just get 5k minus 4. Then I would multiply by 3 and divide by 7. Multiply by 3, divide by 7. Cancel, cancel. 5k minus 4 equals 7 goes into 84. 12 times 3 is 36. Again, this can all be done in decimal. I'm just doing it, on my head looking at my notes, but of course you can just do these calculations in decimals. Then we would just add 4. 5k equals 40. K is going to equal, divide by 5. Let's move this over here. K is going to equal 8. Okay, so product of the roots for this problem being equal to 84 means that k must equal to 8. I do not know of a direct way to do this in Desmos. I mean, other than, technically you can use a slider and like manually add up the intercept values of it, if you graph out the function, but I do not know of another direct way to do the problem in Desmos, besides the way we do it by hand here. Okay, next up we have, I think this is a repeat question that we've seen before, but basically what's going on here is we have a right triangle, okay, B, A, C, B is the right angle that's given, AC is 35, AB is 11 less than that, which means it must be 24, and then we have a perpendicular line segment, essentially an altitude, drawn from point B to the hypotenuse, and it intersects the hypotenuse at point D right here. What's the ratio of BC to BD? This one is done using similar triangles. And essentially what happens is when you have a right triangle and you draw an altitude to the hypotenuse, from the right angle to the hypotenuse, it makes two new smaller triangles, and all three triangles in the picture are now similar to each other. So the two smalls and the one overall large, they're all similar. So what you have is basically, okay, a large triangle right here. I'm going to draw them all the same orientation, which is much easier to understand. Okay, so we've got this. Then the other triangle that we're looking at will have BC and BD. So it's going to be basically this triangle right here, but I'm going to orient it such that the corresponding sides match up. The way I can just confirm that I do that properly is, say this is 50, right, angle A. That means this has to be 40 because 50 plus 40 is 90 and 90 plus 90 is 180. It would also mean that this is 40 and it would also mean that this is 50. So now when I match things up, I need to have, first of all, D is going to be here because D is the right angle. And then remember I said this is 50 and I said this is 40. So now in this picture of this triangle, the yellow triangle, okay, the 50-degree angle corresponds to B, which matches up with A. So the 50 has to go with the 50, so B has to go where A is, and the 40 has to go with the 40, which means C goes where C is. Okay, so all I did is I took this and I basically kind of flipped it over. So now it looks the same as triangle ABC. So BC to BD, basically hypotenuse, which is BC, to, I'm just going to call it like, side opposite 40, opposite the 40-degree angle, right here. So the ratio of these two sides, since they're all similar, will be in the same ratio, i.e. proportional to the same corresponding sides in the other one. So in other words, in ABC here on the left, the hypotenuse, which is AB, is 35, AC, which is 35, and then the side opposite the 40, which is AB, is 24. Therefore, the correct answer to this problem is 35 over 24. You could enter it like that. You could also enter the decimal equivalent, which should be 1.458. Let me just double check that in Desmos, make sure I'm not misreading my handwriting. Yeah, 1.458, and whether you round it or truncate it, it's going to be the same regardless. Okay, so again, this is how you solve this problem using similar triangles. All right, next up, number 6. This one is actually a tricky one when you first read it, but when you think about it, it actually is not that difficult to figure out. So you're told about this polynomial function. It has 4 x-intercepts, okay? These 4 points given here. So 4 zeros, 4 roots, however you want to think about it. So q, which is a constant, is equal to the y-coordinate of the y-intercept, and r is equal to the product of the roots. Okay, so essentially the way that we figure each of these out is, okay, r is straightforward enough. The roots are the same as the x-intercepts you see here. So you're just taking -7, -4, 2, and 3. Okay, you're just multiplying them all together and you get positive 168. For q, the only way that I've been able to figure this out or think about this is basically if these are x-intercepts, then when you go to write the function in intercept form, basically you can write its factors like this, right? Because x plus 7, that factor corresponds to an x-intercept of x equals -7, right? Because if you set this equal to 0, then you have to subtract 7 over, and that's where the -7 comes from, and so on. Basically, it's the opposites, of all the things you see here. So now, if you're going to find the y-intercept value, that just means for every x, you plug in 0. So notice what you end up doing here is for the y-intercept value, you technically end up multiplying the values. It's like the same numbers as the intercepts, except obviously the signs are opposite. So it's 7 times 4 times -2 to -3. So it's like the same numbers, but because there's an even number of negative signs, basically there's 2 of them, it's going to be positive and it's also going to be 168. So now you just add these together. Correct answer is just going to be 336 for this one. Okay, now the problem is I'm assuming that in the actual problem in the test, there's like, I don't know, there's some wording or some description or something that tells you that like there's no something about like the a leading coefficient out here, because for this polynomial, if there was like a 2 or a 1/2 or whatever, any other number out here, obviously that would be multiplied through by all these numbers and that would change this value. So there's got to be some wording in the official test question, this appeared on the exam to basically tell you that like I don't know, the leading coefficient is 1 or something, something like that. Or they gave you some generic general form which had like x plus p, x plus q, x plus r, x plus s or something, and it just, there was just an invisible 1 in front of it. All right, let's go through this next problem. Number 7 deals with an isosceles triangle. Basically ABC. Total perimeter is 90. AB and AC are the same, and you also know AB is 35. So that means that AC is 35. Also 35 and 35 is 70, and you subtract that from 90. That means that this has to be 20. You're also given the height of this triangle, and we want to know, well, what is A? So all we have to do is drop down an altitude here. Technically, it's going to split this into 2 congruent triangles on the left and right, meaning that this is going to be 10 and this is going to be 10. And then we just go through, and there's multiple ways you could do this. So the way that I actually did it was I said I made this 15 root A, and then I set up Pythagorean theorem. 15 root A squared plus 10 squared equals 35 squared. It's going to be 1225. 10 squared is 100. This 15 squared is 225. Root A times root A is just A. And then I just solved this equation for A and got my answer. So 225A is going to equal 1125. A is going to equal 5, just dividing by 225. So that's your answer. However, an alternate way you may want to do this, just what may seem more obvious to you is if you just label this x and then you do the x squared plus blah blah blah, okay? So you would get x squared equal to 1125. And then you would have to basically simplify that into 15 root a, meaning x is really the square root of 1125, and then you'd have to realize that 11, 1125 obviously has a factor of 15 in it, so you'd have to go through and say, okay, 1125 divided by 15, that's 75. Okay, 1575, and then you'd say 15 and 5. Okay, now I know that this simplifies to just 15 root 5, and then you could say, okay, well, that's obviously a has to be 5. So if you wanted to do it that way or think of it that way, that's perfectly fine. Again, you get the same answer. It's the same, general approach using Pythagorean theorem, but, just a slightly different way to think about it or approach it. All right, next up, question number 8. Here we have another percentage question. Basically, they tell us that A is 484% of B, so A is 4.84 times B. And we know A is 0.0088 times C, because it's 0.88%, and then you divide by 100, move the decimal place over 2 more spots. Okay. So now they're asking, though, the question's asking about C as P percent of B. So we can set these two equal now because they're both equal to A. So we can do 4.84b equals 0.0088c. And again, the way this is worded, it says C is P percent blah, blah. That means we want C alone on one side and every other number on the other side. So I would divide this by 0.0088. So C is going to equal whatever 4.84 divided by 0.0088 is. Okay, 550 times 550 times B. Now, that's not a percentage, that's a decimal equivalent. So technically, since it's asking for the percentage, this would have to be multiplied by 100. So your final answer for P would be 55, let's see, 55,000. And that's what you would type in, as the final answer. Note that I think there are some versions of this question where everything will be the same as what I've written here, except it will say what is P over 1,000, and then in this case you would take the 550 multiply it by 100 and then divide it by 1,000. So in that case, in that example problem, your answer would be 55. But regardless, this is still kind of the general approach of how you could go through and how you could get it. Now, you can do this problem entirely in Desmos, but it does still require a little bit of work. Basically, the approach, if you're going to do this in Desmos, what you have to do, or what I have to do is, I would start with A as 100 as the number I picked, and then I would take these first two equations. So you still have to know how to set up these first two equations, and then basically solve for B and solve for C based on A. Like these way the equations are given, you can't define B and then find A, and then use that to necessarily get C because of how it's given. So, for example, what I would do is the following. So I'd start off again. I would just say A is 100, and then for the B value, essentially, if you divide both sides of the equation by 4.84, so you get A divided by 4.84, okay, that gives me my value of B. Same thing for C. That's going to be A divided by 0.0088. So now I have B and I have C. Okay, the thing you have to be careful though is if you just type it in the way it is, C equals X percent of B, all right, it gives you this weird, just linear, line which is not what we want. So you technically have to switch the sides. You have to put the X percent of B part first and then equals C. Now we're looking for a vertical line. And the thing is, the answer, we're going to have to zoom out, a lot. There's our vertical line. Notice it's at 55,000. That's the answer we got originally. So that's what tells me that it is correct. All right, now problem 9. Here we have, again, this is a repeat question that we have actually seen before. Different numbers for this one, but same, again, same basic setup. So you have a map, and this map is 55 inches per side, and 1 inch on the map represents 17 total miles. Then you have a larger map, okay, where the sides are 90% larger than the original one, the 55-inch one. So if you do the calculations out, 55 plus 0.9 times 55, you can just do it in Desmos. It's going to come out to 104.5 centimeters. Or you could technically just do 55 times 1.9. That's kind of like the shortcut approach. In any case, once you figure that out, then what you have to do is, okay, on the small map, you have 1 inch for 17 miles, okay, and you have 55 inches. So it's like 1 inch, 17 miles, okay, but we have 55 inches. So, how many miles does that equal? Well, you see here, you just cross multiply. Basically, it's just going to be 55 times 17. All right, so it's 935 miles is what, say one full thing is represented on the map. Now, we have that same distance, here of 935 miles, except we have 104.5 inches instead of 55. So basically, we want 935 miles, put that on the top, put the 104.5 inches on the bottom. Then we divide these. It comes out to 8.9479, which means you could either report 8.947 if you truncate it, or 8.948 if you round it. All right, and this is basically the number of miles per 1 inch, which is what they're asking for. What is the actual distance represented by 1 inch on the larger map? All right, and just to confirm that, we go to Desmos. And I'm taking the 935 total miles and dividing that by 104.5. Yeah, 8.947. Wait, actually it looks like, oh yeah, it is sorry, it's just 8.947. The 9 I was putting after the 7 was actually the problem number in my notes. So ignore that. It should only be 8.947 because the 3 will not make a difference with rounding it. So rounding and truncating are the same. This is the only acceptable answer. All right, the last question here. You're told that you have an expression. This expression kx represents the decrease of a positive force. I mean, whatever, that doesn't matter for the problem. That acts on an object by 0.21%, and it wants to know what's the value of k. So, in other words, this kx is equivalent to a decrease by 0.21%. What that really means is you are decreasing it by, in decimal terms, 0.0021. So if you think about like 1 as your starting value, okay, like you start at 1, and then you decrease it by 0.21%, i.e., you make it go down by 0.0021, then it would go to 0.9979. So again, I started at the value of 1. I decreased it by 0.21%, which meant I decreased it by the decimal equivalent of 0.0021. And if you just go to Desmos and subtract that, you should get 0.9979. All right, and we should also be able to, let me see here, 0.21% of 1. Yeah, you could also even type it in with a percentage like this, and you could see it gives you the same answer, okay? So now, what is the value of k? So what they're asking about here is really like, what is the multiplier that you would multiply the force by in order to represent a 0.21% decrease. And so it's just this number. It's just basically, in other words, like if you had some force and you multiplied it by this, the new value that you got would be 0.21% smaller or decreased from the original value, or 0.0021 less than that. So this is just the answer basically right here. I guess it would only be 0.0021 less than that. Again, if we're starting at 1. You start at any other number, the actual difference would not be 0.0021. It would be 0.0021 times the value of your original thing. So just to make sure, to clarify, this 0.0021, technically this needs to be multiplied by the original value, whatever it is, but because I used 1 here, that's why it doesn't change. That's why it's just 0.0021. So just to make sure, that I'm clear on that. But the correct answer in this is 0.9979. That is the number that you multiply the force by, which would represent a decrease of 0.21% on it. All right, so this was part 3 of the November 2024 digital SAT math questions. If you have any questions, comments, alternate solution methods, corrections, please feel free to leave them in the comments below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Check out part 1 if you haven't done so already. Check out part 2 as well, from the November test. And of course, check out the older test problem videos as well. We've got August, I've got June, I've got October, and I've got a couple even from way back in May. So hope you enjoyed this video, and I'll be back soon with more SAT math related content.